To make a Poietique patch from scratch, we're going to be concentrating on audio in this case, and the first thing we're going to do is put the object analog to digital converter, ADC tilde. This is a very important object because it will allow us to take raw audio data from the microphone, and this is something that we can use in a digital sense. It will convert that into data. So it is the input microphone. The next thing we need is a very important object that's very useful in much sound design called fiddle. So this one is fiddle tilde. It is a frequency analyzer. It was designed by Pickett as well in 1998 and has various functions that can be used in many different ways to use the data input of sound. Here you can see it running just with my voice, and you're able to get the output of the pitch, the raw pitch, the amplitude, and sinusoidal components. What we're going to do in our case is simply use the pitch. So I'm going to take the outlet of the audio to digital converter. We're going to add that to fiddle. I'm going to also put a comment here. Okay, the next thing we want to do is to see the results of our microphone input. So I'm going to put a number box simply, attach the left-hand outlet of fiddle to the inlet, and there we see the number that's related to the tonality of the input, which in this case at the moment is my voice. See? And when it's not my voice, it seems to be the internal running of the computer. In order for us to avoid these tones being too high, or sorry, not too high, rather too low for the speakers of my laptop and yours, we're going to use an arithmetical operator. So it's another object. That's very useful and can be used with many different ways, but it's basically plus. And in this case, we're going to plus 100, so that our tonality is always going to stay in a more higher range. To this, I will add another number box. And this will give us the result. So we see it's just literally adding the numbers up. And in our case, this will give us a higher frequency, a higher pitch. But this number could be anything. You can change this to anything you want, and it could be something that you change depending on what you're using as your output. So if you're using a huge sub-bass system, then you might want to leave that as it is, or even minus some numbers, but maybe not too many. So next, in order for these numbers not to jump from one to the other in a kind of tonality way, we want to create a kind of curvature, so that instead of this kind of jump or shift in pitch that's very harsh, we're going to have something that slides. To do this, we're going to add two objects. Well, we're going to add a message and an object. The message is $1. Now, $1 is taking the numbers and is going to relay those numbers in a way that is either 0, which it does nothing, it just relays the numbers directly as they are, or for us we're going to put $1000, which will run through the numbers. We're going to add our number box to that, and we're going to put the object line 1 by adding our dollar message to line 1. We should start to run through the numbers, and to see this in action we will put another number box. I mean, theoretically these number boxes aren't really necessary, this should do the job, but it's a way for us to visualize what's happening. So as you can see, when I'm talking, we're running down to 150, 160, where my voice tone is. And then when I stop talking, it raises to the level of the whistle within my computer, which is around 118, but plus 100 to 118. And instead of jumping to that number quickly, it will run to that number. Like that. So next we're going to add an oscillator. So we're going to put the object SC tilde. This is basically a frequency generator. And with that we're also going to use a signal operator, which is another object using star, meaning multiplier, and the tilde for audio signal. Let's put that here. I'm gonna attach that to the left as well. This next object that we're going to put is very important, but before I go on with that, I'll just show you the oscillator. In the help, you can also have a look at the different things you can use, how you might use the oscillator in different ways, and how you might visualize what's happening with that. The helps on the objects are very, very useful for determining other ways you might change the parameters or use them in different contexts. So the next thing we need is a couple of objects. One is the horizontal slider, which will help us define the amplitude. So these also run from 1 to 127, and we use this with the object dB to RMS, which means decibels to RMS, which is basically analyzes the volume and can make sure that you're not going to overpower your speakers. So it will basically convert this to help convert the analog output of this to something that is relevant to your speaker output in your computer or elsewhere. So that's dB to RMS. We're going to add that. Oops. I'm going to add that here. And then we're going to put that here. We can also put another number box so that we can see what's happening with our slider. So at the moment it's at 0, and if we go into play mode, we can move that. We can see the slider going all the way up to 127. So it's a very important object, really. And this we're going to attach to the, we've attached to the right hand side of the signal operator. So they're both working together. At this point we can go directly to attaching the object digital to analog converter tilde, which changes the sound back to, changes the digital data back to sound. So hang on a second, if we connect these, we can hear, if I put it into here, we can hear already the first part of our patch working. Now the next thing we're going to do is we're going to visualize this by adding a peak view meter. In order to visualize this, we're going to add the object view, which we'll connect using also, oops, we don't want that there, we just want to put an object here, and the object is pvu tilde. Which helps us to see what's happening with the pitch and the volume. Voila. If you look at the help on this, it will also explain how this is working and how you might use it in different ways. Peak view meter. Okay, so if I add some comments so we don't forget what's going on here, output comment. Right, now that we've done that and we've commented on it, what we're going to do is we're going to create a second one for the right outlet. This one we're going to do just simply by copying and pasting everything below the fiddle line. Copy, paste. Right, here we go. We can put it in a way that doesn't interfere too much with what we've done. We're going to connect fiddle from the same outlet to here, and instead of having 100 plus 100, we're going to have plus 100.5. This will destabilize the left and right sound slightly, so we'll have a different kind of we won't have a straight tone but a kind of reverberation or a battement between the sounds. And we're going to connect the signal operator here to the right side of digital to audio output. Now, normally, if we put that in edit mode, increase this volume, we're going to have a movement between the two sounds. Boop, boop, boop. Okay. So now we've got our basic droning feedback system. We can also connect the output of this volume control to this one so that there is something that remains the same and go together. But afterwards this one we can also change on its own. Voila. So the next thing is to shift and create delay and feedback in the environment of our patch.